Wij gaan back to the future.
Jan en ik gaan op 17 april naar de Microsoft Technologies en .NET conferentie van Nederland. FutureTech 2024 in de Jaarbeurs Utrecht.
Hey, weet je wat echt super tof is?
Nou, vertel.
Wij mogen gratis kaartjes weggeven. Wat moet je ervoor doen, Ronald?
Nou, dat is heel simpel. Volg ons op TikTok. Daar zijn wij tegenwoordig ook te vinden.
Vet, hoor.
Ja. En op YouTube en maak kans op 2 van deze tickets.
Ja, vet. Hey, mis je kans niet en dan zien we jullie daar.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes en voor iedereen. Ik ben uw gastheer Ronald en ik zit zoals altijd met...
Hallo Ronald.
Jan Stomphorst. Welkom Jan.
Ja, welkom Ronald. Hey, KubeCon?
KubeCon, ja zeker.
Nog steeds hè?
Zeker, tof. Hier zo. We zitten hier in de Media Lounge, hebben we gewoon onze podcast spullen neergegooid. Of neergezet, laten we het even netjes houden. En we hebben gewoon echt hele toffe gasten.
Ik ben wel benieuwd wat we nu weer te vertellen hebben.
Ja?
Of wat ze nu weer te vertellen hebben.
So I will kindly introduce our guest. That's Benjamin Elder from Google. Welcome Benjamin.
Thank you.
And Antonio Ojea. Yeah, that was the Spanish variant, sorry. Also from Google. Welcome guys.
Thank you.
So I will start with Benjamin. Benjamin, can you please introduce yourself to our listeners?
Yeah, hi, I'm Benjamin Elder. I'm a senior software engineer at Google. I work on the Kubernetes kernel team. I've been working on Kubernetes in the space about 7 years full-time, just about now. I started with a Google Summer of Code project. I worked on kubeproxy, implemented the IP tables backend. And then I joined to work on the engineering productivity team, and that's where Kind came about.
Okay. And Antonio?
Yeah, I'm a senior software engineer at Google too. I joined the project in 2019, I think. I was always a network engineer, and then I started to work as a side project on Kubernetes. That's when I met Benjamin and Kind, and since then I started to contribute more and more to Kubernetes, and now I DL on SIG network and in SIG testing.
Okay. And you had a lightning talk yesterday about Kind.
Yeah, I mean, we use Kind for everything. So any talk is going to have Kind on that side. But
So for the people who don't know what Kind is, can you explain to them what is Kind?
Sure. Kubernetes and Docker is how we came to that name, thinking we were very clever. It supports Docker and Podman at this point. But the idea is that you can run a local Kubernetes cluster, and each of the nodes is a container with containers and containers, like if you're familiar with Docker and Docker. Same idea, bit more involved, but unless you boot up Kubernetes clusters, you can have multiple clusters or multi-node clusters. We built it because we needed to test Kubernetes itself locally when we're developing the project. And we wanted to be able to run that locally without VMs and from source code.
In what situation would I use it?
Yeah, so like I said, originally we used it to test changes to Kubernetes itself, but it's taken up a fair bit of popularity for you're developing a Kubernetes application. I actually gave a talk on this a little while ago. I really recommend people to, start with, you have Antonio has this design, the test pyramid. So you want to have your unit tests and then your integration tests and work your way up to, okay, now I need to make sure that I'm working in a Kubernetes cluster. And, some applications is overkill. They really don't need to. But particularly if you have applications that interact with the Kubernetes APIs or with each other through like custom resource definitions, and there you have this distributed system going on, then it's very challenging to test that without actually having an API server, without actually running your pod specs. And it's cheaper and faster to do this locally before you do maybe your final prod qualification or pre-prod qualification, something like that, in a real cluster that looks closer to how you're going to finally run your application.
There's another aspect that you can use is for networking. Despite we don't want to implement all the networking features in Kind, it's very flexible, so you can test. So when I started the project was because IPv6. In Kubernetes, we don't have any IPv6 support. So we talked, I went to Barcelona QCon, we met together, I showed Ben the plan, and we implemented IPv6 in Kind and dual stack. It was first CNI in the history of Kubernetes.
Oh, nice.
IPv6 and dual stack was KindNet, that is CNI, that we did. all what Ben says is true, but if you go to any network plugin CNI out there, it's using kind in the CI because it's super flexible. You can do a lot of these E2E or integration tests with the platform, just fiddling with the network bridge and all these things, but it's super useful for networking.
What are the limitations of kind at the moment?
So fundamentally, you're sharing the host kernel, and that causes some problems. We talk about containers as if they isolate everything. It's a nice little box. It's not quite true, and it becomes painfully obvious when you're doing something like kind and really sort of abusing the container interface. There are some things like, for example, I notify watches that users tend to trip over where they're not namespaced. The limits on them are actually shared across the host, all namespaces. So any of your workloads, any of your kubelets, everything is all consuming from that because it comes out of memory in the kernel. So you have that. Similarly, if you're trying to test things around resource limitations more broadly, things like memory and CPU limits don't work very well when you're nesting containers, and each of the nodes is also currently reporting the full host's resources. So you're not like breaking it up.
Yeah.
I have some talks about how we might be able to change that, but it's always going to be a bit leaky. If you use like a VM-based solution or a remote cluster, you're going to have a bit stronger isolation. This isn't very important when we're testing the logic and the components and how they talk to each other. It's a problem if you're like, pre-prod qualifying. You want to make sure that you can actually fit within your limits and that these things, you have the right amounts for that sort of thing. And occasionally you may run into some issues with a few things in the kernel that are not sandboxed.
And is something like eBPF something you're looking at, or is it some totally different beast?
I don't think that's going to solve this problem, but eBPF is used with kind. Cilium runs some of their CI with kind.
Yeah, so as Benjamin said, the problem is that isolation, right? A container is not a thing, it's not a VM. So we need to do a lot of fakes on the lower level systems to try to be more VM-ish for the node, right? And eBPF works, but when you are developing kernel technologies, you need to be aware that you are not you don't know the kernel. It's a namespace kernel. So that's why he says, depending on what you're developing, you need to take this into consideration. But Sirion is using kind in CI.
Yeah, okay.
That's one of the biggest eBPF projects, right?
Yeah.
Are there limitations? You say it's only for testing? Because if somebody uses this in production, then not...
It's optimized for testing. It really shouldn't be used in production. It's good for application development, for testing. If you're using this in production, I mean, setting aside any of the security problems with the way that it runs, just the fact that it's not, it's not a platform that provides things like security patching, upgrades. If you're running a Kubernetes cluster in production, you should really have a plan for how you're going to upgrade to the next version and pick up those security fixes just in Kubernetes itself, let alone everything else. Kind is designed around running a snapshot of Kubernetes in a single container image that has everything we need. So when we build the Kubernetes source code, we collect everything together, we pack it in this one Docker container, and then we run it. That's really great for testing. It means that you can do things like offline development, and you just need to have the kind binary, Docker, and this one image, and you're set. And then there's some tooling for if you want to have your images available offline as well. But if you're running in production, you don't want one snapshot of Kubernetes. You need a system that's going to stay up to date.
Yeah.
You have to have a plan for that. Kind doesn't cover that. It's not built for production.
No, that's awesome. that's great. That is
Good to know, yeah.
Good to know. Because if everybody says people are going to do it.
Yeah.
We
actually have some semi-reasonable production usage. What they're doing is they're not serving workloads. They're using it for cluster API style clusters where you're running a Kubernetes controller to manage the cluster itself. So then you have this bottom turtle problem. Well, where do I run the controller to begin with? I don't have chicken egg. Where's the cluster come from? So kind gives you a really simple, cheap way to throw up a cluster, get the controller running, bootstrap, and then you get rid of the kind cluster and you pivot to a real cluster. And then typically you would take your first real cluster and use that to manage further clusters. So you're using it very transiently locally to run some controllers to bring up your real infrastructure. And that's used in production, but you're not having any user traffic hitting this.
If you're testing is your test the same as a production Kubernetes? How much? That's a better question. How much differs kind from the real Kubernetes?
The thing is, I can guarantee that I able to reproduce 95% of the bugs that we receive in Kubernetes. I think that's a good measure for knowing how good it is. So there are things that if you have bugs with kernel drivers or all the stuff, you cannot do that.
Yeah.
But bugs with, I create a service and suddenly it's not balancing the traffic okay, or this controller is misbehaving, you can reproduce with that.
Yeah, for some really advanced workloads, you might be dependent on the specifics of the kernel you're running on. Maybe you're doing accelerators and you care about GPU drivers or something like that.
Yeah, like AI, stuff.
So in that case, you can certainly do it with kind, but you're not necessarily matching your production environment. That's going to be a little bit on you, because those things are inherited from the host that we're running on.
Mm-hmm.
Right? So we don't control the kernel. We don't control the drivers in the kernel. Another place that comes up is, if you have like really heavy storage usage, you probably care about the storage class you're using and the storage driver. And of course, we have a toy local one that doesn't really look like you. Like it's good enough for if you're just like, my application needs a persistent volume and I'm going to store some stuff on it. But for some very advanced users tuning things on their storage driver, that sort of thing, well, it doesn't match, because if you're using like, GCE persistent disks, well, you're not using that in your kind cluster. That driver is not made to run locally. So we have some local driver, actually from the Rancher project, local path storage, that will give you a PV implementation, but in like the loosest sense.
Okay. But if you have created PV in Kubernetes and the PVC, that's...
Yeah, you'll get a PVC.
You get PVC.
Yeah, you get a PV provision from your PVC. It's just that... for certain workloads, you might actually notice the difference between running on the cloud SSD versus on a local PV, or enforcing limits on it. That's not something that's implemented in that driver.
Okay.
So in general, resource limits are very leaky, and anything that's kernel scoped, like drivers, time, bin format MISC, if you're doing cross architecture things, like the hack where you can run a container from another architecture, you have to register some handlers in the kernel, those global namespace, identify watches. There's a handful of things like this that if you're a very advanced user, you're going to start to notice, oh, well, because this is all on one Linux kernel, my different kind clusters and things are sharing all of this, and these details are dependent on the host environment.
So autoscalers are not working properly also?
Right. We don't have auto-scaling. Typically what we tell people, if you want to test your application's behavior with node changing size, is actually to just use taints. You can just mark a node and say, this isn't a schedulable for me. That should be fine. If you have you generally don't have workloads that are ignoring all taints unless you're developing system stuff yourself. And if you're developing system stuff yourself, there is tooling available where you can add and remove clusters. We've worked with to support the cluster API project a bit. We have some friends over there, and their development tool, they have a Docker provider, and it's using some kind tooling, so it can implement the full cluster API interface. We don't usually use this for testing Kubernetes because it itself needs controllers running. So you have a kind cluster that starts this other kind of cluster.
You get kind of an inception.
You get kindception and things, but like it actually works really well for like certain things. But for like most Kubernetes applications, just a single node with kind is going to boot really fast, and it'll be fine. If it's only something like, I don't know, I'm a DB sysadmin and I want to play with the parameters to make sure I'm getting the best performance on my disk, okay, well then kind's not going to be a great fit for you. In fact, really any local cluster is not going to be a great fit for you. You should probably get a cluster that looks very close to production, maybe not in scale, but like it's very similar, at least like one node, so that you know that, okay, I'm using the same driver and that sort of thing. If you're really looking at something really performance sensitive and that kind of thing. But if you're trying to test the logic of how things run in a cluster, how your manifests deploy, that sort of thing, it's a Kubernetes cluster. It's fully conformant and it provides everything that you would expect.
There is another interesting aspect that we have an API and some people use it for create these advanced scenarios. For example, there is this keywalk project that use kind and scales to thousands of nodes, right? So that's the flexibility. If you want to get a bit more advanced, you can use this API, or you can just use bash script and this Docker feature, right? I know people that to emulate disruption, they just do Docker pods on the node, right? And then check the behavior of the controllers or whatever thing. So that's the flexibility, right? Is you have this API, you have this cluster, and you have a lot of possibilities to interact with the cluster from outside and emulate these environments and all.
Cool. If you do your exams, so if you take in CKE exam, are those also kind clusters?
I've definitely seen people using kind cluster to study for it.
Oh, to study, but also in the if you take your exam at the Linux Foundation, are there also kind clusters?
Isn't that production?
No, that's.
I'm not sure what they're using currently. I know some folks at the Linux Foundation use it. I know it was in some of the keynote stuff again today, but I'm not sure what they're using for CKA. I think it certainly could be.
Yeah, I was thinking about applications, and one of my applications would be learning.
Yeah.
Learning and taking exams.
Yeah, it's very popular for that. I said, I'm not certain about people taking exams with it. I'm not sure that like the current requirements on that. I know it's evolved a bit, but I know people that have done all their studying with it.
I just go to any talk and you see the demo, and I can say that a lot of them use kind just for the demos.
That's awesome.
For trainings and workshops, I see a lot of people.
I think it's really popular with people that are working on Kubernetes itself and some of the close extensions like CNI around it. Like, for example, Istio was one of the first adopters outside of the Kubernetes-project for some of their CI. So here, where you have people giving demos for like tooling they're building around Kubernetes, this is pretty common that they're using it. I mean, oftentimes for them, they might even be depending on Kubernetes changes that haven't released yet. And so like kind of makes that really well. We're constantly supporting the absolute latest source code. If you build the latest kind code, it will work with the latest Kubernetes code.
Yeah, that was my next question.
You felt it coming.
Because can you build kinds yourself then?
Yeah.
Okay.
So it's a Go binary. So you can go get it, or I guess it's Go install these days, or we have pre-built binaries. It's a very, very, very small Go binary. That was something else we were looking for. You can embed it in your like test applications. We have people that write. There's a lot of Go in the Kubernetes ecosystem.
Yep.
So people will write their tests in Go.
I'm smiling about it. Yeah.
A lot. So
Why not Rust?
it exists up these days.
I think that is the Docker picket Golan, and
Because Go is awesome, but it's slow.
Is it low?
Slower than Rust. Rust is
There's always trade-offs if you want the absolute maximum performance, right? You can write hand-tuned assembler, but like maybe
of course.
like for a lot of people, I think one of the reasons that Kubernetes use Go, and I've talked to some of the people that started the project, is there were actually a bunch of like C++ and Java devs at Google, and I think some like C and things like that at Red Hat. But they wanted something that was going to have good performance, but was very approachable to build a community to develop software around. Rust is a very challenging programming language. I like Rust, but I think that it can be a little tricky to build a large open source project around. It's a very complex language, and it was still evolving at the time. So I think because Go was more mature in the earlier days of the project, and it was very approachable for new contributors, but it had plenty of good performance and lots of concurrency primitives, it worked really well for building something like Kubernetes. And people looked at Kubernetes, they see Kubernetes using it, and they use it to build things that are going to extend Kubernetes.
Yeah, of course.
This is an ecosystem.
Yeah,
right?
it's ecosystem.
So you could probably bootstrap a Rust ecosystem today, and I think that the tooling has made Rust a lot friendlier these days than like earlier days of working with it. But you still have to build a Kubernetes ecosystem there, and there's so much momentum around the Go ecosystem for Kubernetes.
That's awesome.
And we work closely. Some of the people in the Kubernetes project have worked really closely with the Go team. Go actually recently rolled out a couple of things that were basically requested by Kubernetes because we've talked closely with them.
Go workspaces. So Kubernetes is unique in the way that it handles the code base, right? There are certain parts of the code that are exposed as modules, and we have to go with symbolic links and so on. And there is this new feature that got Hawking implemented like 1 or 2 weeks ago that you use Go workspaces, so you have this virtual.
So Go itself is aware that we have the multiple different things in the repo and they're being linked together and that it's all in one place. Also, we we care a lot about Kubernetes being very stable for everyone.
Yeah.
But one of the problems we run into is that Go supports 2 releases. They release twice a year. And Kubernetes has 3 releases a year and a slightly different support model. And we would wind up having a Kubernetes release that was using a Go version that wasn't supported anymore. But if we updated Go, then there might actually be some observable behavior changes. Things like maybe the encryption libraries changed a little bit or something like that. So the Go team actually supports now. You can say, I'm using this level of Go, and it will maintain compatibility. So we can keep updating to the latest Go toolchain with all the latest Go changes, but we can make sure that there's no compatibility difference, that everything will behave the same from observably as the user. Anything that's a breaking compat change has a way to turn it off, and you can just tell it, I'm sticking to compatibility with the version that we ship Kubernetes with, that we've extensively qualified with, that we know exactly the behavior, and Go will continue to behave that way. And that was a really big piece of work from the Go team. And we're really thankful for that. So, this is really good interaction between the projects.
Bij ACC ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie.
Oh, that's awesome. And I was just thinking, what do you think about, you've got 3 releases of Kubernetes in a year. What do you think about an LTS version? Because a lot of people are talking about an LTS version, and I've got an opinion of that, but they're talking about that.
That's a hard topic. There are several problems. Yesterday was one of the main talks in the Contributor Summit, and there are several challenges, right? Because it's not only Golang, it's Containerd, for example. Containerd is going to release 2.0 and they are not going to make it in 1.30. So the problem is that when they deprecate 1.7, we are still going to support Containerd 1.7. So we end in this problem that we are releasing with some version that is not supported by other projects. And like this, there are a lot of questions. So everybody wants LTS. We need a lot of questions, and we need to find this answer. So we are working on that. I don't know what is the solution, but it's a complex problem.
I think there's also, LTS doesn't exactly have any, long-term support, but what degree of support, and what does it mean, right? You could have just security patches and bug fixes. How long is the support? Is upgrade still supported? If we're supporting these super rovers, are you going to jump forward? Kubernetes has limited skip upgrade support today.
It's getting better.
You can skip. Well,
it's getting better.
Yeah, so you can skip upgrade for your nodes, but to remain officially supported, you actually need to upgrade your control plane all the way through currently, and that's a very, very, very challenging problem because of how the APIs are constructed. If we were to have skip for something like that, and even to just support allowing this skew on the node version and let you have multiple versions skip for the nodes. I mean, people who are developing Kubernetes now have to say, well, when I'm graduating this feature, we have to wait another release or 2 before we can wrap up everything because we have to maintain this extended compatibility. And so already that, we had to do this cost benefit analysis for that one. And so, a member of the project, Jordan Liggett, did a very thorough analysis of how much would this have cost us over the past few years, which features would have been delayed, and how would that have worked. And that one was a good trade-off, and I think gives people a bit more flexibility on their upgrade frequency. But, depending on what you actually go with LTS, it could be a lot more work for the project, and not to mention all the dependencies and things like that. Yeah. Or I've been working, so I have a couple of hats within the Kubernetes project. I'm on the steering committee, and so this is the governance body over the project. I'm a lead in SIG testing with Antonio, technical lead, and I'm a technical lead in the Kate's Infra SIG that runs the infrastructure provides the infrastructure for the project. And I can tell you, we've had some challenges over the years with making the infrastructure sustainable. Kubernetes is a really expensive project to host and develop. And we are thankful for sponsors from many companies, including Google and Amazon, many other, Fastly. We have some resources coming from Oracle soon. Equinix has been a supporter for a while, and DigitalOcean. And we're hoping to get some more companies on board, but it's expensive to run all this. Like Kubernetes supports a 5,000 node scaling target, and we mean it. We run tests with 5,000 VMs in the cloud. So now imagine we start supporting more releases for longer. Are we going to keep running those 5,000 node tests on these older releases? Like, that's not cheap. That's expensive. We've actually had to, be a little careful with how much we run with the current set of releases and try to make sure that this remains sustainable, even as we get more resources from vendors. So that's one of the problems. You have people that want LTS, and, we understand that there's some constraints and things, but they also have to remember that, this project costs a huge amount of resources to run, and just supporting things longer is not free. I mean, even aside from all the people effort and the dependencies we have to integrate with. So, I think we're going to make more strides in making it easier for people to have smooth upgrades. There's a bunch of work on that. Some of my teammates are working on some really interesting projects in that space for how can we make Kubernetes upgrades easier and safer so that people can stay up. But we also know that there's some use cases where the upgrade frequency is just the problem. So the project is really talking about it, but it's challenging to pin down because there's so many options for what do you do with it, and they all have different trade-offs, and it's hard to figure out what makes sense. I mean, another thing that is even right now with just the 3 release model, if you have a patch and you need to backport it to previous releases, usually the code looks similar enough that you can just cherry pick the patch. And if it's a cherry pick, then it's very easy to rubber stamp and say, this patch is there, we ran the tests and it still works. The further you go back, the code may not work anymore. You have to rewrite the patch to target this older version. You really need to be more careful to make sure, even if the code merges fine, does it actually work right? Because it's interacting with other parts of the system that are now, multiple releases back. And, these things are somewhat, there's a lot of volunteer work going on. So you have to tell people, hey, can you start doing this for more releases? So it's a really interesting topic. I think that the project wants to do more there. We're just not sure how much to do.
I heard a lot about rumors about we want LTS, and because a lot of people think 3 times a year, it's a lot of work to upgrade.
Yeah. So one of the things we're looking towards is, can you, you already should be able to not do this 3 times a year. You just have to think about upgrades a little bit different. So what you can do right now with the support we have is you can actually upgrade once a year. What you need to do is you'll have to upgrade your control plane through the versions. Mm-hmm. So it will be multiple upgrades batched together for your control plane. For your worker nodes, you can actually just jump forward. You can leave them there. Once the control plane is fully upgraded, you jump the worker nodes forward and you're good. We have the -3 SKU support for worker nodes now and for all the components that need to work there.
Yeah, it's in 127, I think.
That sounds right. -3.
Yeah, it was. I think what was.
But even if Kubernetes supports things like this, does your CNI, does everything else, and in your cluster,
that's not a dependency.
Let's say Kubernetes has LTS itself. Well, then we're also implicitly asking all the other projects to start supporting along your Ingress, your CNI, and so on. And right now, I'm not sure if they've all caught up with the N-3 support. I suspect a lot of them have not.
I think that at the end it's 2 questions. It's what people really mean by LTS, if it's Kubernetes LTS or is my entire configuration cluster, whatever LTS. And the other is, do you want LTS just because you cannot upgrade smoothly? Because if that's the problem, maybe we can improve the upgrade to be...
No, because like a Red Hat or an Linux distribution has LTSs. I'm in the other camp. I think you have to upgrade 3 times a year.
I work at Red Hat, so I know what you're meaning, and I know the work that it requires.
I mean, we know that there are people that have to work in regulated environments where if you tell them that this is a different version, a different minor version, suddenly it changes things. If we somehow just said Kubernetes never has a new minor version, everything is patches, and we'll just pretend that that's fine, then they could probably do whatever they wanted. But as soon as it becomes visible that we're changing versions, now you have a regulatory question. You have to have everything qualified and permitted for use in this environment. It's a very high overhead for some of these users. And, maybe that's a case where you need to pay a vendor to get support for this because the Kubernetes project only has so much resources volunteer. But if there's really widespread demand, then we can try to answer that question. And I think the N-3 support gets you closer. I'm not sure if it's sufficient for everyone. And so I understand that for some people, they need answers for how they can not do 3 times a year. But for the most part, I think what I want to see is that we make upgrades smoother, because it's just a problem anyhow.
They are smoother because there are less breaking changes. That was my problem, because I had some time ago we had the ingress change, and that was a big issue, and we had the Docker container D flip over. That was a really big one, and it's awesome, by the way. But that was a really big one. But you will have breaking changes. But the last 3 versions, they're great.
Yeah, we've introduced
done. I'm done.
We've introduced policies to minimize that. Like the ingress one hit people so hard because Kubernetes has an alpha beta GA for features, but the problem we ran into was, well, these have different levels of support and expectations on them. But if you leave something beta for years, it's effectively GA and people depend on that version. So we actually have policy to prevent that now. The feature either has to get out of beta or it's going away.
Awesome.
As a feature owner, if you're shipping this feature, you have to continue to make progress to drive it towards GA. There's like a timeline now. It cannot stay perma beta. And we've done some more things to tighten that up so that the Kubernetes cluster you're getting with everything turned on by default should be very stable, supported things that are not going anywhere. And you can explore alpha features, and we hope you will and give us feedback, but maybe not in production.
So, thank you very much. How do you see both the future of Kubernetes?
They can see the future of Kubernetes, probably.
There is a lot of work now. You see everything is AI/ML. There are new challenges, right? Because Kubernetes was built to handle CPU and memory, and now you need to handle GPUs. GPUs that are connected with super complex network topologies. There are new hardware, and if Kubernetes is able to absorb these domains without breaking the existing clusters, I'd say that has a great future.
Yeah, I think that, and because of that space, also some of the ways that you schedule and run the workloads, Kubernetes is really built around things like deployments where pods are disposable, and we're just driving towards this eventually consistent system that has overall what you need running. And maybe something stops running for a minute, but it scales up another one. But if you're running some really expensive AI training tasks, maybe you really don't want those pods dying, or you have batch workloads and things like that. And you can do it. I mean, we run Kubernetes as CI on Kubernetes. It's a very similar problem, but it's not as optimized for that. And there's a bunch of work going on in the space to adapt to these new workload demands and trying to meet users where they are there. I think we're going to continue to see more of that. Like if past AI/ML, there'll be new hardware accelerators, new ways that people want to think about running their applications, and continuing to evolve the API to cover all of that.
Okay.
Yeah.
Awesome. Okay. Really awesome.
Well, guys, thank you so much for sitting here with us and having a chat about current Kubernetes and all the other stuff. So we're going to keep following your development very closely, and I hope to talk to you again in the future.
Thanks for having us.
Thank you.
Okay,
Thank
see
you.
you. Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl, via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.